Amid the ongoing United States government shutdown, NASA scientists continue monitoring the interstellar comet 3I, also known as Atlas, even as much of the agency's public communications remain paused. This week, NASA officials are preparing to brief Congresswoman Anna Paulina Luna, who requested new images and data for public analysis. Meanwhile, Harvard astrophysicist Avi Loeb has renewed calls for transparency, citing signs of brightening and irregular motion following the comet's recent solar pass. Global observatories have launched a joint monitoring campaign extending through early 2026 to track the comet as it moves away from the Sun. Since its discovery in mid-2025, 3I Atlas has steadily passed through the inner solar system, reaching perihelion on October 29th. Around that time, astronomers observed a sudden surge in brightness, likely caused by intense outgassing as sunlight struck previously shadowed ices. Spectral data revealed brief jets of water vapor, carbon compounds, and trace metals. While such activity is normal for comets, what drew attention were small irregular shifts in the comet's trajectory, prompting refinements to orbital and rotation models. These deviations are not evidence of artificial influence, but provide valuable insight into how interstellar objects behave under solar radiation. Despite the federal shutdown, NASA teams at Goddard Space Flight Center and Jet Propulsion Laboratory have maintained essential tracking. A briefing with Representative Luna is planned to discuss upcoming data releases and reassure Congress that monitoring continues uninterrupted. Luna's request was coordinated with Avi Loeb, who has advocated for open access to the latest images. At the same time, the European Space Agency and several university observatories have joined the observation network. Right now, the comet is about 300 million miles from Earth and fading, its once bright tail growing dimmer with every passing day. As it drifts farther from our planet, it becomes more challenging to spot with the naked eye. But astronomers remain determined to track its journey. Even as the comet slips away into the darkness, it continues to captivate scientists and stargazers alike, reminding us of the fleeting beauty of these cosmic visitors. Fortunately, high-sensitivity telescopes are still able to collect valuable spectral data, even from such a great distance. These powerful instruments can detect faint signals that would otherwise be lost, allowing researchers to keep studying the comet long after it has faded from view for most people. By analyzing this spectral data, scientists can observe how the comet's coma, the cloud of gas and dust surrounding its nucleus, is evolving as it moves away from the Sun. This information is crucial for understanding the physical and chemical changes taking place within the comet. This phase is actually pretty crucial, analyzing the outward trajectory of the comet as it leaves the inner solar system. Tracking its path helps astronomers predict where it will go next and how it interacts with the solar wind and other cosmic forces. The changing light curve, which measures the brightness of the comet over time, really helps researchers model the comet's density, spin, and internal composition. By studying these variations, scientists can infer details about the comet's structure and what it's made of, offering clues to its origins. All of these data will feed into the International Asteroid Warning Network's campaign, a global effort that brings together experts from around the world to share findings and coordinate observations. This campaign is running from November 2025 through January 2026, marking a critical window for gathering as much information as possible before the comet becomes too faint to study. The goal is to build the most comprehensive dataset yet on an interstellar object, compiling observations from telescopes across the globe and creating a detailed record for future generations of scientists to analyze. As the comet recedes into deep space, it leaves behind a legacy of data and discovery, ensuring that even as it fades from view, it will not be forgotten. 3I, or Atlas, stands out as a truly extraordinary visitor to our solar system. Its rarity isn't just because it hails from another star system, making it only the third known interstellar object to pass through our cosmic neighborhood, but also because it offers a once-in-a-lifetime opportunity for scientists to study material that formed around a completely different sun. In many ways, Atlas acts as a living laboratory, allowing researchers to directly observe how material can be exchanged between planetary systems, and how the building blocks of planets and life might travel across the vast distances of space. Spectroscopic measurements of Atlas have revealed intriguing similarities to comets from our own Kuiper belt, suggesting that some chemical processes may be universal across the galaxy. However, what's truly fascinating is that certain chemical ratios, especially those involving carbon to oxygen and nitrogen-bearing compounds, are noticeably different from what we see in local comets, hinting at a unique origin. These differences suggest that Atlas may have formed in a much colder, more distant protoplanetary disk, possibly orbiting a small faint star, far from the warmth and light we associate with our own sun. By unraveling these details, scientists hope to refine our models of how water and organic molecules are transported throughout the galaxy, deepening our understanding of the cosmic processes that may ultimately lead to the emergence of life elsewhere. The comet's irregular acceleration is still under study, puzzling astronomers and sparking lively debate within the scientific community. Despite years of observation, the exact cause behind these unpredictable movements remains elusive, making this comet a fascinating subject for ongoing research. Most researchers think it's due to asymmetric venting, where jets of gas erupt unevenly from the comet's surface as it heats up near the sun. These powerful outbursts can act like tiny thrusters, pushing the comet in unexpected directions and altering its path through space. This is probably caused by uneven layers or rotation, since comets are made of a patchwork of ice and rock. As the comet spins, some areas get more sunlight, causing more intense venting and further complicating its motion. But yeah, there are still some minor anomalies in the data that don't fit neatly into current models. These unexplained quirks keep scientists on their toes, encouraging them to dig deeper. Loeb and his colleagues emphasize the need for unbiased investigation, encouraging the scientific community to keep an open mind and rigorously test every hypothesis, no matter how unlikely it may seem at first. Not because anyone suspects artificiality or anything outlandish, but because science advances by questioning assumptions and exploring every possibility, however remote. Looking into unexpected natural forces can reveal new physical processes, and sometimes the most surprising discoveries come from investigating what doesn't quite add up. NASA and ESA both maintain that all observations so far are consistent with a natural comet, and their teams are working together to share data and insights. Still, they agree that extended monitoring is definitely warranted, as every new observation could bring us closer to unraveling the comet's deepest secrets. Unlike the limited data during the 2017 Oumuamua discovery, this campaign is, highly coordinated. More than a dozen institutions are sharing real-time observations through the International Asteroid Warning Network, involving both professional and amateur astronomers. Data collection spans multiple wavelengths, visible, infrared, and radio, to map gas emissions, dust density, and compositional changes as the comet cools. Preliminary results suggest the comet's composition may evolve as it moves away from the Sun, potentially forming a faint ion tail. If confirmed, this would be the first time such behavior has been recorded in an interstellar comet with high precision. Each dataset helps scientists determine whether interstellar comets are common messengers from other star systems or rare fragments ejected under exceptional conditions. 3I, also known as Atlas, also illustrates how space science and public policy intersect. Congressional interest in a single comet would have seemed unusual decades ago, yet growing demands for transparency make oversight, pretty much inevitable. Lunar's involvement underscores the broader cultural and scientific significance of space discoveries. NASA has pledged that all data collected during the shutdown will be publicly released once normal operations resume. The Pentagon's All-Domain Anomaly Resolution Office clarified that 3I, Atlas, poses no security threat, highlighting structured communication to prevent confusion between scientific events and speculative narratives. International coordination continues through the European Space Agency and the LEL Observatory in Arizona, with the goal of tracking the comet until it fades beyond detectability. Observations will include polarization studies to assess particle size and dust structure, providing insights into its formation. Looking ahead, the Vera Rubin Observatory will soon scan the entire sky every few nights, capturing more data than ever before with its powerful new instruments. This will enable the detection of more interstellar visitors, revealing objects that were previously hidden from our view. Events like 3I, Atlas, could become annual as our ability to spot these rare travelers improves. These discoveries will transform such encounters into a new field of comparative studies of interstellar comets, deepening our understanding of the universe. For now, 3I Atlas continues outward, faint but measurable. Within months, it will move beyond most telescopes' reach, leaving terabytes of data that will shape interstellar research for years. This comet has united scientists, lawmakers, and observatories worldwide, a reminder that even across light years, our solar system is never truly alone.